All right, today I'll be doing some basics in trig ratios. After that, I'm also look at some ACT questions concerning trig ratios. All right, so trig ratios and ACT questions. All right, so what I have here on the board is a right triangle, triangle ABC. So they'll go angle A, angle B, and angle C. And then I have the sides labeled. That's side A, that's side B, and that's side C. All right. So before I get into that, I just want to talk about how we organize labels when we're drawing triangles and shapes. So one of the main things that we like to do is we like to use uppercase letters for the angles. So if you see an uppercase A, it's talking about the angle A. The uppercase C is angle C. That happens to be my right angle. And the uppercase B is for angle B. All right, so that's what the uppercase letter represents. It represents the angle itself. Now, opposite of whatever your angle is, that's where the lowercase is. All right, so if angle A is over here, directly opposite is its side, which is lowercase a. There's C, directly opposite of C is a lowercase c. B, opposite of B is a lowercase b. That's how we like to label our triangles to keep everything uniform. All right, so here's your first three, your main three are sine, cosine, and tangent. Sine is your opposite side over the hypotenuse. Cosine is your adjacent side over your hypotenuse, and your tangent is your opposite over your adjacent. There's different ways that you can try to memorize this. The most popular way is something called SOHCAHTOA. I'll spell that out in the next slide. You can look those up. It's probably hundreds and hundreds of videos that explain that acronym. All right, so the other thing I want to focus on is this symbol right here. That symbol right there means theta. Kind of like in algebra, instead of using like a question mark, the most common variable is the letter X. The same thing applies when we start getting into trig ratios. The most common variable for any given angle will be a theta, all right? So when you write down a trig function, you just can't write down the trig function by itself. It has to be a function of some value. So we have to put something there if they don't give us a degree or a radian to work with. So that's like a placeholder, all right? But that's the most common variable that we use for an angle. All right, so the next thing I have to get into is the labeling of your triangle. If you label your triangles first, you can write your function second, all right? You label first, write second. All right, that's what we're going to do. Anytime you have a right triangle, the first side that you want to locate is the hypotenuse. You find your box, your 90-degree angle, you go directly across from it, and you write HYP. That's going to be the first thing you find. The first thing you find is your hypotenuse. The next thing we do is find the theta, or the angle that we're coming from. Since I put my symbol here, I find this one next and I go directly across from it. And whatever I do at that point, that's now my opposite. Because what I'm saying is that this side is opposite from the angle that I'm coming from, all right? Because everything's going to be based off an angle that you come from. So this is opposite of the angle in question, all right? Opposite of the angle in question. And the side that's remaining is my adjacent, all right? Is my adjacent. There it is. Literally, that's the order that I go in. Locate the hypotenuse. Find your angle for opposite. And then get your adjacent. So just like I said, you label first. We got this labeled, then you write second. And see, if we look at the rules, it says opposite over hypotenuse. That's what my sign is. All I do is find opposite and I find hypotenuse. There's my A over C. A at the top, C on the bottom, because opposite is at the top, hypotenuse is at the bottom, A over C. Then I look at what this one says, adjacent over hypotenuse. Okay, so there's adjacent, there's hypotenuse. So we're talking about B over C, side B over side C. And now this one says opposite over adjacent. So I come here, there's opposite, there's adjacent, right? A over B. All you have to do is make sure these are labeled correctly. Your rules are already written. All you do is transfer them, and they have to sit exactly where the rules say they should sit. If opposite is in the top, do not write it in the bottom. It's just that simple, all right? Nothing else to it. You label first. Find your hypotenuse first. After that, find your opposite, label it. After that, find your adjacent and label it. The rules is going to be your job to know these three, all right? There's different tricks to memorizing them if you have trouble memorizing them, but your job, your responsibility will be to make sure that you have this much correct, because if you can label correct and write this correct, everything else will fall into place. All right, so I'm looking at an ACT question. Literally, this is an ACT question. We have a triangle, and it asks for triangle, for right triangle, ABC, what is tangent C? And there's my triangle, and there are my answer selections. All right, there we go. So everything is within the question that you need and within the diagram. So the first thing, since I'm trying to figure out what the tangent of C is my angle in question. See what I'm saying? So C is my angle in question. That means I get to put that symbol right there. I put it where angle C is, and my labels will be based off of coming from wherever this symbol is. Now I label based on this location. The first thing we do is label. We're going to label the hypotenuse first, and the hypotenuse is there now. So that's my hypotenuse, HYP. All right, second is the opposite. So I find this and I go opposite over here. So I put opposite over here. Opposite. And the third thing, whatever's left, that happens to be my adjacent. So I label adjacent. That's the first thing you have to do, label those sides first. Remember, it's your responsibility to know your rules. So the tangent of a function, tangent C, is opposite over adjacent. That gives me my C over A, because by the labels, opposite is C, adjacent is A. Opposite is C, adjacent is A. So I have to do C over A. That's pretty much the end of this problem. Literally, all you have to do is know the rule and know your labels, and you can pick the correct answer. That happens to be A. All right, this is the next question. It states that the hypotenuse of the right triangle ABC shown below is 18 feet long. The cosine of angle A is 4 over 5. About how many feet long is segment AC? All right, so there's my diagram, my triangle ABC, and it wants to know the length of segment AC. And segment AC is the side across the bottom. All right, that's what we're trying to figure out. How long is that side across the bottom? I put a question mark on AC because that is the side length or the segment in question. And that keeps me on track for, when I'm working my problem out, why am I doing what I'm doing? It's so that I can get to that question mark. All right, that's why I'm putting it there. So remember, everything that you need is always given to you within the problem and the diagram, right? So what I'm going to do is I'm going to take some information right here. That part right there, it says the cosine of angle A is 4 over 5. I'm going to create a separate triangle using these ratios. All right, that's what I'm going to do. And what I say, I still stand on firmly. If you label your triangle, you're putting yourself in the best position possible. So we have my triangle labeled. I know what my cosine is. Remember, you have to know your labels. You also have to know your functions. Cosine is adjacent over hypotenuse. All right, adjacent over hypotenuse. So if I have a 4/5, that means my 4 is the adjacent and my hypotenuse is the 5. You get what I'm saying? So I took this text and threw it into my triangle with the correct labels, because this is how we're going to get this problem figured out now. So the triangle on the left is the triangle directly from the problem. That's the one that was given to us. That's the one that we didn't have to figure out for ourselves. It was just given to us this exact way. The smaller triangle, the one that's on the right, is the one that I had to pull from the text and draw myself. Now, if you pay attention to the way I have these triangles arranged, I have an 18 over a question mark, but over here I have a 5/4. If that doesn't ring a bell, this now goes into something different now. We started off by using trig ratios, but to get to that question mark or to get to that answer, now we're going to go into similarity proportions, that type of thing. So I'm about to set this problem up. And there it is. I have 18 over x. Now I have a 5/4. And if you remember how this works, anytime you set two ratios equal to each other and you're looking for a missing value, the word we like to use is cross multiplication. So basically what that means, if you can diagonally multiply to get to your solution. Yeah, so 5 times x is 5x. 18 times 4 is 72. Divide both sides by 5 and you'll have your answer. All right, so those are the two examples that I wanted to go over today, using trig ratios and pulling from a ACT workbook with some ACT questions. Number one, just as I said before, label your triangles. Find your hypotenuse first, opposite second, adjacent third. Hypotenuse, opposite, adjacent. Make sure you get those labels correct first. Number two, you have to know your rules. Your first three, you got to know those first three: sine, cosine, and tangent. If you know those three and you know how to label, it is very, very, very hard to mess up these numbers. All right. So practice on those. Stick to those rules. Those rules work. They will get you to the correct answer every time. They will get you to your destination. All right. So I hope that helped. Don't forget, like my channel, subscribe, send it out to whoever you think may need to learn something or is trying to practice on stuff. I have lessons going up every single day I show up to work.